Hello everyone, let's solve some Leetcode today. So today we have Leetcode 35, that is search insert position. This problem is really easy. In this problem we have a sorted array and all the integers in the array are distinct. No duplicates are present. And we have a target value. If this target value is present at the array, we have to return its index. In case the target value does not exist in the array, we have to return an index on which this target value would have been present in case it existed. Now notice that we have a sorted array in the question. It means the binary search option is open for us. Also we can see that question itself asks us to write an algorithm in order of log and time complexity. And this is a big hint towards binary search. In this example, we have to find the target 4 and we can see that it also exists in the array. Where does it exist? Well, 0, 1, 2, 3, 4 and 5. So we can see that it exists at the index 3. So we have to return 3 as answer. And this is what the problem is asking us. In this particular example, we have a target of 4. Now we can see that it does not exist in the array. So what do? We simply return the index at which this 4 would have been present if it was in the array. So here we have 1, 2, 3 and then we would definitely get a 4 on this particular place instead of 5. So what is this particular index? 0, 1, 2, 3. So here also we have to return 3 as answer. Here we have the same example again. First we will use target as 6 and then we'll use target as 4. We will try to figure out how to apply binary search in both these situations. We don't have 4 in the array, but we do have 6. So in the binary search, first of all we have to set the L as 0 and the R as the last position in the array. So L is equals to 0, R is equals to 5 in this case. Then we will figure out the mid. Mid is equals to 0 plus 5 divided by 2 is equals to 2. At the index of 2 we have 3. Now 3 is less than the target value of 6. It means we can shift the L to mid plus 1. So now L will come here and the R will stay at its own position. Now the new mid will be 5 plus 3 divided by 2 is equals to 8 divided by 2 is equals to 4. And here we can see that on the fourth index we come here as mid. We check if the value at this particular place is greater than the target, we will shift the R to mid minus 1. If it is less than the target, then we simply shift the L again mid plus 1. Otherwise, if it is equal to the target, we will simply return this particular 4. As we know that it is basically equal, then we can simply return 4 as answer. Now let us try to understand how it will work for something that does not exist in the array. So then again, we have L is equals to 0, R is equals to 5, that is the last position. And then we have this mid is equals to 5 plus 0 divided by 2 is equals to 2. We are not taking decimal values, we are only taking the integer values. So here we see that 3 is basically what? Less than our target, right? So what we will do is we will shift the L to mid plus 1. So L will come to this position, that is 3. So L right now is 3. Now again we will calculate mid, that is 3 plus 5 divided by 2 is equals to what? 4. Now here we come and we check if it is greater than, less than or equal to our target. Clearly greater than our target, right? So we will shift the R to mid minus 1. And mid minus 1 is basically right now L, right? R will also come to this position. And now we can try to figure out mid again. So this time mid will be 3 plus 3 and divided by 2, that is equals to 6 divided by 2 is equals to 3. And then we will check this value. Is this greater than or less than our target? Well, it is clearly greater than, so we will again shift the right to mid minus 1, that is 3 minus 1, that is here. Now at this position the L is greater than R, so we can basically break the loop. L greater than R, break. Now notice the indexes at which left and right pointers are present. Left is at index 3, R is at index 2. Now left is basically at index on which the target value would have been present if it was actually existing in the array. What this means is that we simply have to return L now as answer. This will be our answer. But the question is why? Why does this actually work? When we notice, we realize that at each iteration we were basically incrementing L by mid plus 1 and R by mid minus 1. What this means is that L will keep on growing in this direction, R will keep on reducing in this direction. So at one point L and R will eventually become equal to each other. And why can I say that they will become equal to each other? Because the mid pointer will always be between L and R, will always exist in this range L and R. So it means that when we are basically reducing R by 1, then either the R will eventually become L, or if at the end we increase the L by 1, L will simply become R. And that is because at some point these two pointers will come to these places. R will be here and L will be here, where the distance between R and L will be single 1. And at this point when we actually try to figure out the mid, then we will go to this particular L and then we will either simply basically decrease this one or increase this one by 1, right? right? We are increasing or decreasing by 1. So they will become equal at one point of time. And in our example, the L and R became equal at this particular position. Now what can we conclude from this? We conclude that we have covered all the elements that were less than the given target 4. Then only we have been able to come to this particular place which is greater than 4. And we have also covered all the elements which were greater than this element and also greater than particular element 4. So we can see that this particular element is basically something which is greater than all the elements which were less than 4, but it is not 4, and also it is less than all the elements ahead of it. We can conclude that out of all the elements present in the array which were greater than 4, this element is closest to 4, right? It is not 4, it is still greater, but this is closest to 4. And we have also seen that we have gone through all the elements that were less than 4. And since L and R are basically equal and we have still not found 4, what this means is that this is basically the position at which 4 would have been if it was in the array. But we actually got the closest element to the 4. Yes, 3 is also the closest element, but we got this particular position because at this position the 4 would have been. And that's why after going through one more iteration and R will be here, we can break the loop and we can simply return L. The time complexity for this particular solution is order of log n because we are using binary search, and the space complexity is order of 1 because we are simply using more variables, constant variables, left, right, mid. We are not actually initializing any new arrays, so space complexity is constant. Let's go through the code solution. We have the left pointer, we have the right pointer. Then we are going in the loop, calculating the mid index. We are checking if the value at mid is less than or greater than target. If it is less than target, we shift the left pointer to mid plus 1. If it is greater than the target, we shift the right pointer to mid minus 1. Otherwise, it is going to be equal to target. In the else, we are simply directly returning mid as answer. In case this entire while loop runs and we reach a position where the R is less than L, we will stop it and we will simply return L as answer. Now let's run it and see what happens. Yeah, so it works and we are getting 0 milliseconds. Don't trust Leetcode compilers for this. If you have a question, topic that you would like me to target, then just let me know in the comments. And now we will meet in the next video. Till then, bye.